Okay, today we're going to talk about slope. Now, when you think of the word slope, even outside of math class, what comes to mind? What do you think of for slope? Skiing. Okay, that's probably the number one thing that comes to mind. You're going to hit the slopes. Okay, now what's a slope for skiing? It's a big hill with snow on it. You hit the top and you slide down the bottom. Okay, what else? What else comes to mind when you think of a slope? After skiing, what else comes to mind? Sorry? Snowboarding, skiing, I guess we can lump those two together. We can look at them separately though, I guess. But it's the same kind of principle, right? A steep hill, okay? Some kind of hill. Bottom line, when we think about slope, we think about some kind of hill. Well, we're not far off. Slope is a measure of the steepness of a line. Okay, it's a measure of the steepness of a line. Now, that's an easy way to think about it. Okay, that's the pre-algebra way to think about it. But next year in Algebra 1, you're going to need to think a little bit differently about it. You're going to have to understand the definition for it. And the definition for slope is the ratio of change in y to change in x. Okay, we're going to be working with graphs. And we know that graphs have x coordinates and y coordinates. We plot a bunch of points, and we draw a line through all the points. And that's how we graph. Now, when we talk about the slope of a line, we're talking about how steep that line is. The way we measure it, the way we calculate it, has to do with the change in y and the change in x. Now, ratio. What does a ratio look like? What's a ratio look like? Okay? Generally, you're a step ahead of the game, in fact. What does generally what the ratios look like?
Fraction.
They look like fractions. Okay? Now, JD said y over x. He's talking about a very specific ratio. Anyone know what ratio he's talking about? Y divided by x, right? Which is what? Where does that come into play? When have we worked with that before? With proportions, exactly. Y over x. Y equals kx. It was the constant of proportionality. K, unit rate. Y per x. We did this already. We did something very similar to this. Well, now we're taking it to a more general pattern. Okay? And the little trick to remember that is going to be very, very helpful for you over the next couple of years. This is one that I want you to memorize. This phrase, rise over run. Rise over run. That's the phrase that's going to always help you how to remember how to find slope. Rise over run. So we've got some graphs here, and I want to find the slope of each line below. Now I'm going to find those slopes using the idea of rise over run. We always go left to right. Just like reading a book, just like reading any math problem, when we talk about a graph, we're talking about it from left to right. So I'll start at this point, and I want to go up to this point. Okay, so I'll start at point, call it point A, and I want to end up at point B. Well, I want to talk about the change in y and the change in x. The rise over the run. How far up we go and how far we go right. Well, to get from A to B, I have to go up 2, and I have to go over to the right 4. So when we say rise over run, we would say m equals 2 over 4. We went up 2 and we went over 4. Well, it's a fraction. What do we always do with fractions? What do we always do with fractions? Simplify. So I wouldn't leave it as 2 over 4. We would say m equals 1/2. Okay? M is the variable that we use for slope. It's the one that's always going to get used for slope. M as in Mike. Okay? So let's do the same thing on number 2. We're going to go from left to right. So let's call this one point P, and let's call this one point Q. I want to go from P to Q. So I want to talk about how far up or down and how far from left to right. Now to get from P to Q, we have to go downward. Okay? I have to go down 1, 2, 3. And then I take 2 steps to the right. So my slope here, M, what do you think moving downward is going to do to the slope? It's going to make it negative. So we go down 3 and over 2. So our slope, M, is negative 3/2. Now I know that's an improper fraction. We're going to stay away from mixed numbers. If we want to make it a decimal, we can. But usually you're going to see your slope written as a fraction, even an improper one. Yes?
Is there any reason why you would not necessarily go on the other side? Or can you do that?
Why to go from right to left?
No, I mean like go on the other side. Yeah, on the
Go
other side of the
from,
line.
yeah, from point P over, go right.
Oh, okay. Go off top, above it. Okay, I understand. The reason that we would go, it's always rise over run. Change in y over change in x. So we want to think about that change in y before we consider the change in x. Take care of the top, then take care of the bottom. Okay? Good question. And really, Willow, you can do it either way. It's just a really good idea to always do the y first. Pick a pattern and always use that same pattern. Okay? Okay, number 3. Number 3 is a little bit different. They didn't give us the graph. So we've got to put these points on the graph. Well, I think we can handle that. The point 0, 3. Where does 0, 3 go? Where would I plot 0, 3? Callie? I would just go up 3. Okay, 0 steps left to right, 3 steps up. And we'll call that J. We'll call this point K. So here's point J. Where's K going to be? Where will I put K? Michael? 0, 3 went here. Where would 4, 1 go? Over 4, up 1. Very good. And there's point K. All right, and then I'll draw a straight line through those points. Straight as we can. Now, I want the slope of that line. So, Seth, how many steps up or down?
Three steps down. And then 4 steps over.
Does that put me on the same point? No. How many steps down? Just 2. And then 4 steps over. Okay? See? So we take 4 steps to the right, but we took 2 steps downward. Now, what's that going to do to our slope? Going downward instead of upward, what does that do to the slope? Makes it negative again. Okay? So what will that look like? Negative what? Right? Negative 4 halves. Okay, what did Ryan give us? What did Ryan give us, B? Well,
Improper.
which is fine. Improper fractions are fine. But what did Ryan do? Something about this isn't correct. JD? He did the change in x over change in y. You gave me the 4 over the 2. Always y on top. Okay, just like when we were doing k. Y over x, same thing. Okay, we need to have the change in y, the rise, over run. So negative 2 over 4. Okay? Can you reduce that for me?
Negative 1/2.
-1/2. M equals -1/2. Okay? So there's our slope. So these are the ways that we can find the slope if we have the graph, if we have the points on the graph. We can count how far up or down, count how many steps to the right, and we can make our fraction. Rise over run. Change in y's over change in x's. Okay? Take a pause for questions. Now, that's how we can find the slope if we have, yes?
How do you know like where to start when you find the point?
Oh, you always start right here at 0, 0. Right here at the origin where those two axes come together. Okay? Now, this is how we're going to find the slope if we have a graph, if we have the points drawn on a graph. Sometimes, however, that's not as easy to do. Okay? Sometimes maybe the points are involving bigger numbers, or maybe there's decimals or fractions. And that can make counting a little more difficult. So, we have a formula. Okay, there's a formula for slope. Okay, so here's how that formula works. If a line passes through the points x1, y1, so whatever x1, y1 may be, and x2, y2. So we have 2 points. If we have 2 points, we can find the slope. x1, y1, x2, y2. If a line passes through those 2 points, then the slope is equal to y2 minus y1 over x2 minus x1. The change in y divided by the change in x. Okay, and this is a formula that we can use for any 2 points. Any points on the line, we can use this formula. Label one of the points x1, y1, label the other point x2, y2, sub the values into our formula. Okay? And if you think about what we said slope is, the change in y divided by the change in x. Well, change. You get change by subtracting. Okay? Just like the difference. Okay? You find the difference by subtracting. Okay, so I want to find the slope of a line passing through these points. I could graph them, and I could sit there and I could count all the steps, or we can use the formula. Now, in order to use the formula, though, what we want to do is label these points. So I'll take 8, -1, and I'll label that x1, y1. Now, when I do that, that means I have to label the second point x2, y2. Now, anytime we use any formula, what do we always do with that formula? What's the very first thing we do with that formula when we touch pencil to paper? Before anything else, we always want to do this with formulas. Okay, we've got the variables identified. Now what? One more time. We have defined the variables. That's what we've done right here. We said that this is x1, this is y1, this is x2, this is y2.
Substitute.
Before we substitute, what do we always want to do with a formula before we use it? Write it down. Every single time you use any formula, write it down. Take the extra 4 seconds it takes to write the formula. That's going to help you use it correctly. So m equals y2 minus y1 over x2 minus x1. Now we've identified those variables. We have that taken care of. So now what we do is we'll take those values, substitute them in place of those variables. So we can say m equals My y2 is negative 7 minus my y1 is negative 1 all over my x2 is 0 minus my x1 is 8. Now once we have the pieces subbed in, then it becomes a whole lot simpler to simplify it, to find the value, to find the answer. Okay, if I have minus and negative, first of all, minus and negative, what happens there? It becomes plus, plus, plus. So negative 7 plus 1, well, that's negative 6. And then 0 minus 8 is negative 8. A negative divided by a negative. What kind of answer is that going to give me? Positive. The signs are the same for division. Your quotient is going to be positive. Now 6/8. Can you reduce 6/8? 3/4. Very good. So our slope for a line passing through those 2 points is 3/4. M equals 3/4. Okay, number 2. Number 2, very, very similar. They've given us 2 points. They want the slope of the line that passes through. So we'll label them x1, y1, bless you, x2, y2. And we're using a formula, so we'll write that formula down. M equals y2 minus y1 over x2 minus x1. Now, we labeled those points for a reason. Okay, we'll take those points that we've labeled and we'll substitute those in. So y2, that's 13, minus y1 is 3. All over, my x2 is 2, minus my x1 is negative 4. Well, 13 minus 3, that's 10. Minus a negative. What did we say about minus a negative? Comes plus plus. So I've got 10 over 6. Now, improper fractions, fine, keep them, great. But what does need to happen here? What does need to happen with 10/6? Riley? We need to simplify. We need to reduce it. To what does it simplify? Five-thirds. So the slope on number 2, or number 5, excuse me, is 5/3. Let's take another time out for questions here. One thing that's really, really important about labeling the variables. Every single ordered pair, every coordinate has an x value and a y value. That's why it's an ordered pair. X comes before y. You have an x, you have a y. You have a horizontal, you have a vertical. You have to have both of them. Every time I look at we do these types of problems, every time we work with slope, for some reason that I cannot figure out, students want to say x1, x2, y1, y2. And I can't figure out why we want to keep doing that. Because ever since we started with coordinates, every time we do coordinates, we have an x and a y. Every ordered pair has an x and has a y. And if we look at these 2 points, this one just has x's, this one just has y's. Well, that would mean 1 step to the right and then 3 more steps to the right. And this would be 3 steps up and then 1 more step up. And that doesn't make a whole lot of sense. Okay? It's very, very important that your ordered pairs, each pair has an x and a y. x1, y1. x2, y2. That's how we label the points. It has to be labeled just like that. x1, y1, x2, y2. The ordered pairs must be labeled that way. Now, we're using a formula. We write the formula down. Michael, what is that formula? Very good. Y2 minus Y1 over X2 minus X1. Okay, Hutch, what is my Y2? 1. Minus, Tyler, what is my Y1? 3. And B, what's my X2?
3.
Minus, Alyssa, what's my X1?
1.
1. So I have 1 minus 3 over 3 minus 1. Well, Callie, what's 1 minus 3? Think about a number line. Here's 0, here's 1, and you're subtracting 3. Which direction is subtracting? To the left, so you're taking 3 steps to the left. Where are you going to end up? Negative 2. Okay, how about 3 minus 1? Positive 2. Okay, well, remember, negative 2 over positive 2, what does that equal? Tell me this. The signs are different. So what does that mean about the quotient? Positive or negative? If we divide a negative by a positive, what kind of answer are we going to get? Negative. Okay? And then 2 over 2 is going to reduce down to what? Not 0. What did we just say a minute ago? Say again? 1. Okay, 2 over 2 reduces to 1. So we have a slope equals negative 1. Okay. Okay, now, that's how we find slope. We use a formula, y2 minus y1 over x2 minus x1. The thing about this formula, guys, remember, this division bar, it says do the whole top, do the whole bottom, and then divide. Okay? If you just type it into a calculator, just like that, 1 minus 3 divided by 3 minus 1, it doesn't know the order that you want. It doesn't know that you meant to do the whole top and do the whole bottom. So do some scratch work. Do some scratch work, do it pencil and paper, just use the calculator at the end to do what you need it for. You could use parentheses. You could put y2 minus y1 in parentheses and x2 minus x1 in parentheses. Okay? Now, there's one more thing that I want to bring your attention to. Okay, and this is something that I hope you already know, but just in case. If, when you're finding slope, you end up with m equals 0 over c. Okay, you get 0 on the top. What does any fraction with 0 on the top equal? You have 0 over any other number. It equals 0. If you have m equals 0 over c, your slope is 0. Now, if a line has a slope of 0, remember we said slope measured how steep the line is. If the steepness is measured at 0, how would you describe that line? Well, all of the lines that we're working with are straight. I think I know what you're trying to say, but you got to work on your words a little bit. I'm sorry? It's not going to go straight down. If it has no slope at all, what would we call that? Perfectly horizontal. Okay? Your slope is 0, the line is horizontal. Now, on the other side of that coin, if you're solving for slope, you use the formula and you end up with some number over 0. You get 0 in the denominator. What happens if you have a fraction with 0 in the denominator?
Equals whatever the top is.
It does not equal whatever the top number is. It does not equal 0. What does this fraction bar mean? What operation is that? Division. Okay. What happens when you divide by 0? Not 0. Tyler, what does that calculator tell you when you're dividing by 0? Every single one of you, pick a number, any number, and use the calculator to divide it by 0. What does it say? It tells you that it's an error. And if you use a different calculator, it might say domain error. But bottom line, the calculator knows it can't divide by 0. That's something that you need to file away, guys. I know we talked about it in here before, but you cannot divide by 0. So if you end up having to divide by 0, we call that undefined. Okay, it's not no slope. We don't say it has no slope. We say the slope is undefined because the calculator requires dividing by 0 and you can't divide by 0. Well, if a horizontal line has a slope of 0, what kind of line would have an undefined slope? Vertical line. Okay, so if you're calculating slope, if you're using that formula, and you end up with 0 on the top of your fraction, hey, that's fine. The slope is 0, and that line is horizontal. But if you end up with 0 in the bottom of that fraction, that means you're dividing by 0, which you can't do. So we say that that slope is undefined, and that's going to be a vertical line. Okay? So to find slope, we got two options. We can use the rise over run idea. If we have a graph, we can count how many steps up or down, and we can count how many steps from left to right, and we can divide. The other option is the formula. If we have any 2 points that the line passes through, x1, y1, x2, y2, we can use the formula m equals y2 minus y1 over x2 minus x1.